We produce the same amount of fish in February and March as we do in August and September because we have the same temperature all year round.
This is a story about feeding the world. By 2050, Earth will be home to nearly 10 billion people. And there's a pressing need to figure out how to feed our growing population sustainably. A big part of that is seafood. Globally, it's responsible for 17% of people's protein intake. In parts of Asia and Africa, that percentage is closer to 50%. But the UN estimates more than 2/3 of fisheries are overused, and the environmental damage is considerable. One solution is being tested at the edge of the Earth, here in the Arctic Circle. I'm in Norway, home to Europe's longest coastline, to find out why the future of sustainable fishing could be on dry land. People in Norway have been fishing for millennia. And today, some of the biggest innovations in aquaculture, or fish farming, are happening here. Aquaculture is actually the fastest growing food supply sector in the world. Salten Smolt is a land-based facility that can produce up to 8 million juvenile Atlantic salmon, or smolt, a year. John Sallebrand is the production manager.
You need to keep them in pitch dark during the incubation period, simulating more or less the nature, because they lie in the gravel during the winter and it's dark. So we kind of mimic nature by having the roe in darkness. So these ones were put into this hatchery around 2 weeks ago, so you can see that they're actually already starting to hatch.
What are those little black dots that I can see in each of these?
That's the eyes.
That's the eyes of the fish?
Yes.
Wow.
So if you look closely, you can actually see them moving around.
After the fish hatch, they're moved into these massive tanks, resembling giant home aquariums. Farming fish like this on land needs huge amounts of water, but Salten Smolt manages to recycle most of the water it uses. That's because it relies on a technology called Recirculating Aquaculture Systems, or RAS for short. It's Mariana Ag's job to make it work.
My responsibility is to take water samples and measure the quality of the water on a chemistry-based level. So I check that we don't have any dangerous levels of ammonia and the other, like nitrate and nitrate.
And why is it important to do that?
It is very important because we need to be sure that we don't have any high levels that can be toxic for the fish.
The ammonia Mariana mentioned is actually one of the biggest waste products produced by fish. So Salten Smolt uses bacteria that's not harmful to salmon, but can eat the ammonia.
So this is the biofilm. So the bacteria that removes the waste product lives inside these. So it's designed to have as much area as possible.
The water here needs to be kept as clean as possible so that it can be recycled and the fish stay healthy. So the machines are constantly filtering out waste and pumping in oxygen.
So this is the RAS systems. So the water is brought here from the tanks, and then it goes through here. And this is the first step, so this is where we remove the particles. And you can see here that the water goes into the drum, and then the particles solidify in the down part. And when it reaches a level, it will start to rotate.
What's these bags so here?
Yes, so this is where we remove the carbon dioxide. That's another filtration system, yeah. So you can imagine that underneath us, all the way down to here, you have the biofilter. So, and then it comes down here. And this is another step where we remove particles.
Particles, what sorts of things are we talking about?
Feces and other particles from the fish or from the water, because we have intake water and we can have some sand and mud that comes in.
Salten Smolt says it manages to convert around 40 tonnes of waste a month into agricultural fertiliser, which is used in farms. So that waste is now part of their income stream.
What is the water consumption here compared to other facilities?
Our flow-through system, that is one department, uses around 18 cubic meters of water each hour. And all 5 departments that you have seen today uses around 1.5 right now.
Wow, so that's a huge difference in the amount of water you're able to use. How much water is being reused here?
In this department that we're standing in right now, around 10% of the water is exchanged each day.
So you're reusing 90% of the water in these tanks?
Yes, that's true.
The 10% of new water they do need is taken from a lake nearby, but even that is tightly controlled to protect local species and keep the water supply running.
What can we see on the screen just here?
That's the dam where we get the water into the facility.
And why does that need to be filmed?
Because it's probably the most critical component of the facility, because if we lose water, it's really critical. So we always have to see water running over that dam.
If you're taking water from outside, presumably there are animals living in that water. Are there restrictions on what you can do and how much water you can take?
Yes, we have strict regulations of how much water we can take out. We have this bigger dam, main water source, and that we have to regulate really strictly, not to empty too much or not to actually flood it. And we also have even a bit more strict regulations because of these red-listed mussels that we have up in the river, so we're not allowed to empty or let the mussels dry.
Besides a huge drop in water usage, RAS removes many of the risks associated with traditional open water fish pens. Farmed fish can cause massive ecological damage if they escape and interact with local species. Uneaten food and fish waste can also cause pollution. And one of the worst things that can happen at fish farms is an outbreak of disease. At Salten Smolt, all of the fish are vaccinated.
Wow, this looks like something out of a factory. There are so many fish working their way through this system. Why do they need to be vaccinated?
Because there's a lot of diseases that can cause a lot of problems. And back in the day, there was used a lot of antibiotics. But now, thanks to all these vaccinations, the antibiotic use is minimum.
What is going on here? Because there is almost a conveyor belt of fish. What's happening?
This is the actual vaccination. The fish will be flipped over to the right side, photographed, sized up, and then delivered to one of these injectors. So it will be injected at the same spot. Independent of size of fish, it will be adjusting.
How are you able to keep the fish so still? Because they're not trying to swim against the current here.
They're anesthetized. So we have a really specific dosage, so they get just the right amount of anesthesia to lie still, pure vaccination, and everything. And you see the fish are going down on these hoses.
Wow, just take a look at that. That is a pipe filled with salmon.
And you see they start to move around more and more along the hose, and it goes around. So when they get out into the tank, it's calculated so the fish are awake when they go into the tank.
While it all looks very industrial and some people might be uncomfortable with knowing this is what modern food production looks like, that doesn't necessarily mean it's worse for the fish or the environment.
When you think about sustainability for fishing, most people automatically assume that natural, wild fish are best. Seeing all that we have seen here today, would that be a view that you would support, that this is secondary when it comes to the welfare of the fish and the overall sustainability of fishing?
Here we can control, it's the control that is the key word of everything. So we can manage the water quality, we can reduce water usage, we have control of the waste.
And that control is really important because all these salmon are going through something called smoltification. It's a process that helps them transition from living in fresh water, where they grow up, to seawater, where they're supposed to spend the majority of their lives. This takes at least a couple of years, and once that's over, Salten Smolt moves the fish to open water farms until harvest. The company says it's managed to tightly control them. It even uses AI-enabled lasers to zap sea lice, for example, to keep the fish healthy.
How does this sort of fish farm compare sustainability-wise to traditional methods?
The fishery methods can be quite rough on the fish with trawling and everything, so it depends on how you look at it, but the welfare situation in fish farms are good compared to, for example, trawling or something like that.
Trawling and other kinds of commercial fishing can cause considerable harm to the environment. Up to 40% of the fish caught are unwanted species, which either die or are discarded. And trawling can also damage the seabed. So scaling up systems like RAS could drastically reduce that impact. But is it possible to avoid open water pens in the rest of the process, like farming fish on land until they're ready for harvest? On the tiny island of Indre Haroya off the Norwegian coast, the company Salmon Evolution is doing just that, by making use of one of the country's most abundant resources, seawater.
This is our water intake station, where we take in the water that we use in our farming operation.
And how does that work?
So we have 2 intake pipes going out here into the fjord. As you can see, we have plentiful access to fresh and clean seawater. So we take in water from 25 meter and from 95 meter, all depending on where we find the best temperature. Like now in the winter, we take in water from the deep, because there you have warmer temperature. And we want to, in our farm, we want to have stable temperature throughout the year, because the growth of the salmon is linked to the temperature, because they eat more when it's warmer, but not too warm. So the ideal temperature is 12 degrees Celsius, or 12 to 14. So now we're going below sea level.
How far?
-5
-5.
meters.
This looks incredible, but my gosh, is it noisy. How much water is working its way through here?
Yeah, so into this facility we have a capacity of 280,000 liters per minute. And that's approximately 1/3 of the water we are using. So it's a lot of water, and there's new fresh water coming in at all times. Now we are on the second stage of the intake station. So here you can see the particle filter.
This is the blue one here.
The blue one here. So underneath us we have the seawater pump. Water is pumped up into this filter here, which is a self-cleansing filter, where we take out any particles before transferring the water further into the facility. So very high filtration, down to 0.1 millimeter.
And so that's what this blue tank here is doing, stopping things like seaweed and anything from the sea from making its way into the water.
Yeah, we want to have, because we are also disinfecting the water, and for the disinfection to have a good effect, you need clean water. So that's why it's very important to filter the water, so that the water is perfectly clean before it goes through the UV disinfection that you have here.
This is the silver one.
Yeah, so here we have the UV lamps, so 4 lamps, and we give the water a very high dosage to kill any unwanted pathogens in the water. So all this is kind of our first line of defense in terms of the biosecurity of the facility, which is very important.
Traditionally, salmon live in the sea. They're used to living with the particles without the UV disinfectant. Why is it important we're doing this?
If you look at the conventional salmon farming industry, you have biological challenges, and from time to time you have diseases as well. And we want to avoid that, and that's one of the benefits by being on land, is that you have a controlled environment and you also have the opportunity to avoid these problems.
The salmon here are older. They were grown in tanks at another facility just a few hours away, until the fish were mature enough to adapt to seawater. They're then brought here and kept until ready for harvest. To keep the water habitable, Salmon Evolution uses what's known as a hybrid flow-through system, or HFS for short.
What are you actually able to control from these screens?
It's everything from the flow of water, the temperature of the water, the feeding of the fish, the adjustment of oxygen, making sure that CO2 aeration is working fine, and so on.
Tell me about the system that you're using to do this. What is the system you're using here, HFS?
It's a hybrid flow-through system, so we provide the fish with quite a lot of water at all times. So about 1/3 is new water, and then we reuse 2/3 of the water. And by doing that, by using quite a lot of water, we give the fish very good conditions, and at the same time we reuse water so that we can control the parameters, for example the temperature, and making sure that we have stable conditions throughout the year.
Are there limitations with this method?
The main limitations in finding places where you have enough water of desired quality and with the right temperature. And then you also need access to power, so grid capacity and access is also a very important part of it.
Salmon Evolution says HFS is simpler than RAS, and that it manages to reuse around 65% of its water. That's lower than RAS, but the company says that's a sweet spot, balancing its costs and operational risks. And because it's taking in seawater at set temperatures, it doesn't need as much energy to heat the water like RAS systems might. The water is also cleaned before it's put back into the sea.
So this is the tank?
Yes, this is where our fish lives. So,
There are so many of them here. How many?
in this tank we have about 60,000 salmon, each weighing approximately 3.5 kilo on average. So this is the last stage of the process, and in a little over a month this fish is being harvested. One of our main benefits is that we produce the same amount of fish in February and March as we do in August and September, because we have the same temperature all year round, and that's a huge benefit for us.
Fish welfare's a big concern here. After all, salmon is a premium product. It's why these companies can afford to use expensive systems like this to breed them. And although it doesn't seem like these fish have even registered our presence, I'm told they have. And as a result, we have to move to a new tank.
The fish before, in the previous tank, were starting to show the signs of stress, which is why we had to move. These ones seem very relaxed and calm.
Yeah, it varies from time to time, but we try to minimize sort of the stress for the fish. We don't want to have too much things going on within the tanks. We want to have it as quiet as possible for them and just give them time to rest and eat and be happy.
Are there any drawbacks for the fish, though, to be in this tank in a really controlled environment? Are there any limits to this for them?
In terms of fish health, fish welfare, I think the best indicator of those things are the mortality and the quality of the fish. Those are objective parameters, and what we've seen now, we've been operating here for almost 2 years now, we have a very low mortality within our system. It's substantially below what's sort of normal in the ocean open up farming, and that's because a lot of the mortality normally comes from when you're handling the fish, when you have to do operations and mechanical operations. We don't do that here. We try to give the fish time to rest and be calm, and that's why we can have a very stable operation with low mortality.
This is just one tank, though, on a site of many.
Yeah.
How many fish do you have here in total?
So in total now it's about 1.5 million.
And as you scale up on this site, the number of fish that you're going to have here is going to increase too?
Yeah, 4 times bigger when we are fully developed and fully built out. We are going to produce 32,000 metric tons of gutted weight salmon a year. That's like 150 million dinner portions a year. So it's a substantial protein production.
I was going to ask, what does that mean for salmon markets around the world, for the food that we eat on our table?
Yeah, it's approximately 3% of the production in Norway today on this site. So it's a fairly substantial operation, but it will take some years to get there, but it's a very sizable operation.
Norway has a unique ecology. It's relatively easy to breed cold water fish in sophisticated systems like RAS and HFS. But if technology like this is to be truly sustainable, it needs to be replicated in other parts of the world.
It's the end of winter here in Norway, and so the snow is just starting to thaw out on the roads around us, but it does make for pretty icy driving conditions. It's such a scenic place to be in, and we're just en route to our next destination.
Roald Jacobsen is a senior aquaculture engineer at Nord University. He's researching the limits of technology like RAS to investigate if it can be used on a range of fish species.
What are you testing for here?
Now we're just drawing a simple blood sample, and we're going to do some tests for some ions in the blood, like chloride and sodium, magnesium. And, yeah. So it's a quite simple, standardized test.
So where have these fish come from?
This fish, it's from a nearby farm. We bought them as to test the seawater tolerance of the fish, so see if they're able to live in seawater. So we test a few fish to check before we put the whole group into sea.
What's the next step?
Next step is we're going to draw some blood from the underneath the spine. Try to hit the sweet spot. This transition from fresh water to seawater is really a critical process in salmon farming. It's a stage that can suffer some severe losses if it's not correct.
Systems that recycle water seem to work well with fish like salmon. But how about with warm water fish, which is eaten in other parts of the world?
This facility already feels very different. It is much warmer.
Yeah, it is much warmer.
What's the temperature in here?
So we're keeping the room temperature on 29 degrees, and we're keeping the water temperature on 28 degrees.
So much, much warmer. What do we have in here? It's a very different type of fish.
It's completely different.
Oh, wow.
This is Nile tilapia.
What are you testing with the tilapia?
They've been really doing basic science on the different genetical mechanisms that's controlling growth in fish. It's one of the most important aquaculture species in the world, so it could be the impact could be quite big. You know.
So this is an opportunity for you to see if the RAS method can work with a different type of fish that's eaten in other parts of the world.
For tilapia, it's really good with the RAS technology. They're thriving well in high densities, and also it's really this facility has really good water, but the tilapia can cope well in much lower standard water than we have here.
So actually the tilapia might be better suited to being farmed in this way than perhaps the salmon.
Yeah, it's quite effective. You can have a much higher density on big fish on tilapia than on salmon. Also the feed, you see this from residue feeds here. The feed is basically a vegetable-based feed, so much cheaper, also more easy to manufacture than.
What does this tell you about the adaptability of RAS in other parts of the world?
It's quite a good idea, because you could grow the fish closer to the market, for example, and also do local species and do local feed resources better.
As someone who has spent their entire career focused on fish and their welfare, are there any concerns about farming fish in this way?
Yeah, there's a lot of different possible issues when you're farming fish in an industrial way, really. It's fish just like us, they become stressed, and they react to acute stress and also the long-term stress just like us. They have the exact same problems. And you see now one of those guys that right there is not aggressive, it's not very kind really. And also water quality in a place like this and different temperatures and all this. You really need to have a good biological competence on these species to do farming.
People here have relied on these waters for their food and livelihood for thousands of years. But to feed the people of the future, it's time to rethink our relationship with both land and sea.
How often do you eat fish in your household?
We eat fish 2 to 3 times a week, salmon and whitefish and different species.
So fish is a big part of you and your family's diet.
Yeah, I think it was bigger in the older generation. They ate much more fish than we do now, but still it's quite the important part there.
Is aquaculture the answer to feeding the world?
Yeah, I think it's one of the answers to feeding the world. It's at least a reliable and good source of a lot of healthy nutrition, like good source of protein and good source of marine fats. And yeah, but they also have some challenges, but all in all, it's a good source.
Is RAS the future of sustainable fish farming?
If you see behind me here, this is the future of sea farming for Norway. The sea-based farming is a really good alternative, but on other places, other sites, RAS farming is a good addition, making it possible to do fish farming in areas that we're not doing it now.
Sustainable technologies are about equilibrium. They're looking for ways to balance the demands of humanity with the health of our planet. When it comes to food, achieving that balance could depend not only on what we choose to eat, but also where that food comes from.